Hey everyone! In this video, we'll be looking at flags across the world and trying to determine which continent has the most similar looking flags. To tackle this problem, we need data about country flags, markedly their images. First, however, I want to introduce you to something. Let's say we want the US flag. We can simply press Ctrl+= and type in our freeform expression, and then get this Wolfram Language one back. Evaluating this expression gives us the US flag. The Wolfram language provides access to curated computable data about millions of entities across hundreds of entity types. One type of Wolfram language entity is a country, and one of its properties is its flag. As you can see, there's this icon-looking object which contains the name of the US in it. This icon is what we name an entity. Entities, like we talked about before, are special objects in the Wolfram language which have many properties that we have stored as built-in knowledge, including flags for countries. We will be using this to do our analysis. We can also use another approach by using the entity but instead typing out the property we want, in this case flag image. We can retrieve other properties such as flag description and so on. Let's start with a simple example of comparing three flags. We will use the image distance function, which measures the abstract distance between two sets of images to gauge their similarity or lack thereof. First, we will retrieve the flags of the United Kingdom, United States, and Australia using the entity value function. I will indicate that I want the flag image of the previous entities, and that I want my entities associated with it. I'll start by computing the image distance between the UK and US flags, and then the UK and Australia using image distance. It seems like the US flag is slightly closer to the UK one. We can also use the nearest function, which gives us the same result. Now, what about all flags? I can retrieve all country flags using the entity value function. I can simply indicate in my entity value function that I want the flag image for the entity type country. I will store that data in my variable flags. We can take the length of our variable and we see that we have 250 flags. Before moving on, let's make sure our data is clean and doesn't have any missing values. We can do so using the cases function and browsing for the head missing. We see that we have one such case. So we need to do some cleaning. I can equate my variable flags to a new expression, where I use delete missing. The length of my flags variable is now 249. Which country was missing though? To find the missing country, we will first create a flag list with flags as values and keys as the corresponding countries, and then we will select the missing values in that association. We can use select and match Q to get that the country with the missing value is Antarctica. We can use other syntax other than using select and the postfix form below. The postfix form we use initially has the advantage of being able to be read from left to right, as we are generating the association, then selecting the missing values. The next one is the operator form, where we have the criterion of select first and then our argument. And then we can also have the following code here, which is the conventional one where the criterion is after the argument and both are inside the operator function. This variety in syntax shows the versatility of the Wolfram language. Whatever form you use is simply a matter of personal preference. Let's explore the data even further. Considering all flags, which is the closest to the UK? Let's use the nearest function for this. We will take the nearest two flags in our flags variable, and it looks like the US is the closest. Of course, the closest would be the UK flag itself, so we have to look at the second one. We can simply use the double brackets and put 2 between to get the second element only, which gives us the US flag. As a side adventure, let's see if we can predict a country based on its flag using machine learning. Let's pick one flag randomly using the random sample function applied onto our flags variable. To find the corresponding country, we can use the built-in classifier country flag to predict it. Using the classify function, We can indicate that we want this built-in classifier and feed our previous output given by the percent symbol. We will use double brackets here to remove the unnecessary listing. We get the Solomon Islands. Nonetheless, in a classification, there will always be different predictions with their respective probabilities. We can output different predictions and their respective probabilities by indicating that we want quote probabilities unquote inside our classify function. We will apply a reverse sort to our prob variable to make sure the highest probabilities are first, and we will also apply the word cloud function onto our list of probabilities. It looks like the Solomon Islands still reign supreme, and all other countries have very small probabilities. Note that country names are sized according to probabilities in our word cloud. Okay, now on to answering our question. First, let's do some data processing. We'll set up a list of countries in different continents and their respective flags using entity value and entity function. For the entity class continents, we will take the flag of each country in there and make sure we have the entity associated with it. Since we want to make a statistical comparison, let's make sure the data is somewhat balanced. We will map the length function onto our variable cont flags and plot a pie chart of it. You will notice that after the argument of my function, I have some options. In the case of visualizations, these are mostly there for stylistic purposes to make visualizations more powerful and more clear. They are denoted through arrows. I can type an option, say plot theme, and indicate a particular theme. Evaluating my new expression gives a more striking looking pie chart. It seems that Australia and Antarctica are very small, and we know Antarctica doesn't even have a flag, so it would be unfair to include these continents. We ought to get rid of them. We will set up a new variable, conf flags cleaned, and use the key drop function to drop Antarctica and Australia. Note that Australia in the above code is not just a country, but rather a region or a continent. Let's move on to our analysis now. How can we define similarity? Let's explore some machine learning functionalities. First, let's get a list of only the flags. We will take the values of our conf flags cleaned variable, flatten the list, and name our flag only list flag list. Let's train a feature extractor function on all flags using the feature extraction function. This basically assigns flags to a unique feature space and uses many machine learning ideas. We can also use image distance here, but I wanted to explore machine learning. To gauge distance, however, we will need a feature distance function. We can get an operator form of feature distance using the feature distance function on our feature extractor, which will serve as our measure of distance or similarity later on. We can compute the feature distance easily by selecting a random sample. I will apply feature distance onto our previous output, indicated by the percent symbol, and indicate that my feature extractor function is fe. We can also just apply our feature distance fd onto our random flags, indicated by the 2% symbols, which indicates to output to go. Let's have all distance values in each continent now. We will use a distance matrix with the feature distance fd as the distance function. We will map our distance matrix onto our conf flags clean variable. We have to clean it up, however. Here, distance matrix returns a diagonal matrix whose elements are the feature distances of two images. So we have duplicates as the matrix must be diagonally symmetric. And we also have a lot of zeros as the diagonal itself would be just flags compared against themselves, which obviously will output 0. To delete duplicates, we will use the delete duplicates function, and to delete zeros, we will use delete cases and indicate that we want to delete all cases of 0. Distance data is then an association with its keys as the continents and its values as the list of distances between flags for each continent. Now that we have a list of numbers for each continent indicating similarity, we need to visualize it to determine which continent is the most similar. We need to see if the data is widespread and dissimilar or localized and highly similar. Let's visualize this data to find out. We'll start with a smooth histogram, indicating that we want a PDF or probability density function plot. We see that most continents have averages around 500, with a slight peak around 100 as well. This is a decent visualization, but not the clearest to interpret. Let's try another one. We can visualize our data with a violin plot, in this case indicated by the function distribution chart. This helps us see the spread of values much better, and we see that Africa, for example, has a very low deviation of values, while Asia has a wide deviation in its flags. Last but not least, we can visualize our data using a box and whisker chart. After this data visualization, one can perhaps point to Africa as being the most similar in flags, as despite being the continent with the most countries, it has very low spread in its distances, as indicated by the range between the 25 and 75% quartiles we see through the box in our chart. I encourage you to explore this data even more and try other ways to visualize it.